it's okay? It's working? Okay. Hello, good morning. Thank you for coming. I will talk about a crazy idea, but seems that maybe it's not so crazy. That's about open designs and open manufacturing. So, it's a very interesting moment of my life where I have been awarded with a program to understand the computing in the next 10 years. Usually, we tend to see things on a very short time. Anyone here had imagined how it will be computing 10 years from now? Could you imagine that? What will be the challenges or what will be the reality in our industry in 10 years? Maybe computers will be everywhere. Maybe we will not need any more energy to power computers. We don't know. So the only thing that we know is when we have computers and humans together, they interact. They talk each other strongly. That's why we had created this center that is the Center for Interdisciplinary Interactive Technologies. We want to understand how humans and computers will interact with each other. And the center is very interesting because in the first floor, it's a full manufacturing facility. So we agree that if we want to transform this industry, we need somehow have some control upon the manufacturing process, because eventually the university can have a different perspective in this kind of industry. And it's happening. Well, you know, there is a very important guy named Peter Drucker. Drucker wrote a lot of stuff about innovation, and he always mentioned what we call the dead valley. The dead valley between ideas and societal transformations, the innovation dead valley. So the way how we try to fix it is building a bridge. And the bridge is based in the process that we call RDTB. So different from companies that usually try to make money from anything that they had developed, we try to believe into the benefit for a given society. And in our process, we have the university, we have an NGO, a non-governmental organization, that can receive incentives from government and industry. And we have all sorts of specialized entities, like non-governmental organizations. For example, we are having the analog switch off in Brazil, the digital TV analog switch off. The government decided to distribute 20 million set-top boxes for the low-income population. So they had created an NGO for that. So these guys are responsible to map who are the poor and who should receive a set-top box in this process. So we have a partner with these guys. We have partners with startups, industry, LG, Samsung, Boeing, and then government. So that's our model. And what is our motivation? IoT is pushing the limits of our industry. It's pushing the limits of we people here at Linaro. Just to give an example, in our country, we have more cell phones than humans, but none have been designed in Brazil, despite we have world-class engineering. And I know that happens everywhere, US, Europe, Asia, Brazil. The design centers are very confined, and unfortunately, we are a very small people in this arena. But however, we affect millions. So the IoT revolution is even pushing these limits. Every time society wants more, but who are the engineers who will drive, this innovation? It's all about the gap, mind the gap, the design gap. So we know that ASICs increase the complexity almost 60% per year, but we engineers, we can feed software, models, applications, designs, only on a growth of 20% per year. And before, people used to imagine that the gap was related to software only. And it's not about software, but it's about the whole ecosystem. Design new boards, manufacturing, certifying. I mean, there is a huge gap in between the SOCs that we have here and the real applications in society. And with the push of IoT, this gap is getting bigger and bigger and bigger. So there are many barriers to the full implementation of IoT in modern society. People talk about energy, people talk about spectrum, but very few people talk about who are the guys who embed intelligence in the IoTs. That is us. So, at the same time that pressure comes, we doesn't still have answers how to fill this gap. So that's our main motivation, how to fill this design gap and help industry deploying better products in industry. So in our case, it was very interesting because we have very fortunate to receive donations from partners. One of our partners, that is a major cell phone manufacturer, LG, partnered with Panasonic, and they give us a state-of-the-art manufacturing line. It's amazing. We can manufacture 10,096 boards per day. But what is the purpose? We are not competing with industry. So the only purpose that we have is fostering innovation. So we can design any board that we wish. We can certify them and simulate them from the electromagnetic point of view. We can simulate them in 3D. We can do the schematics, the layout. We have screen printing, pick and placement, and a refusion oven with 20 steps. So just to give an idea, this machinery can inject 60,000 components per minute. It's a very unique situation. And the purpose here is not to compete with industry, but to collaborate with that and try to find out another dimensions of innovation. Anyone in this audience need some manufacturing and never had access to a common formal infrastructure? Just give me a call, you know. We are manufacturing a lot of innovative devices on the energy industry, water management, defense, aerospace. Many niches that before people doesn't just did that because they doesn't have access to the means. And I truly believe that all this machinery are get smaller and smaller. I will show you some examples, but with very few dollars, you guys can buy what we call pocket manufacturing machinery. And eventually you can do that at home. So we believe that in future, industry will be fully transformed by these movements. So that are the machinery that we have to do really small series. Let's say that I want to do 2 or 3 boards. So at the same time that we have an oven that has 20 meters, we have this small one from a German company named LPKF. It's a programmable oven. So let's say that we just need to manufacture 1 new 96 board. I doesn't need to turn on a oven with 20 meters. I have that small machine, and I could do just 1 board. We have also very small pick and place, this machine here. Let's say that I want to inject 110 components, 50 components, 3 components. So that's another thing that we're observing. Machinery are getting smaller and smaller and compact. And again, cheaper and cheaper. Some people are saying that maybe in future, we will have circuit 3D printers. There are a lot of discussion about that in industry, and maybe that will happen sometime soon. Also, we have equipment for certification and testing. So someone had asked us how we are testing and certifying the 96 boards. We have most our equipment for doing electromagnetic and temperature testing. And even we have a recent project where they want to do naval surveillance. So these boards need to be dropped on a very aggressive maritime environment with a lot of water, salt, and temperature, and corrosion too. We also have equipment for signal analysis. And yes, can we manufacture 96 boards? We are just doing that this week. There is a project from a designer named Linaro. Linaro had designed a board named Guitar. And in our machinery, we're just taking 65 seconds to assemble a single board. And it's just a movie. It's a little bit boring, but we can show the machinery pick and place and process in the oven. So you just inject components from one side, and then you have the board on the other side. It's not so easy, like I'm saying, because there is a lot of back processing. For example, the procurement, we are talking about 300 components, the quality control, and that are the limits of the university. So the easy way to fix it, we just start up companies. We call fabless companies. These companies don't have a factory, but they can use our facilities. Since we keep the certification process under control, we guarantee that our machinery is certified. There is several standards to guarantee. That's why Panasonic is one of our partners, because they guarantee that all the time our machinery reach industry standards, everything goes fine. And then these startups, they are fabless, they don't have a single equipment, but they have the capacity of assembling. So we have created this concept of fabless, one-stop shop manufacturing for IoTs. So you want to manufacture 100 IoTs, 200, 1,000. We are doing that in a very cheap way. And we are partnering with silicon providers and component providers to have the access to low volumes in low cost. That's a paradigm that we're breaking. So that is it. I did a very brief presentation just to have some audience. I know that we have few people in the audience, but probably these people is very interested to see how we can cross the design gap regarding design and manufacturing. Thank you. And I'm available for questioning. So any questions?
Very interesting what you have built up here. One of the things I see with the 96 sports ecosystem is there are not many partners building mezzanine cards to enable specific features on the graphic board or on the high keyboard or any of the others. You certainly have the ability to design those cards, build those cards, but do you have the ability to sell them and distribute them worldwide?
That's a perfect question. I have attended at least 4 sections during this week. For example, the last one that I had attended was the section on deploying software for set-top boxes. And the presenter, at least 4 times, excused himself because the board doesn't have a tuner. So, for example, we need to enable the 96 boards for set-top box, designing mezzanine boards with tuners for broadcast TV. I was very happy because just now That was one idea that we have last year. Adding cameras. The 96 boards are superb for video surveillance on industrial applications. We can embed infrared cameras, high-definition cameras for any kind of surveillance. And until recently, we don't have a single camera attached to them, and Arrow just announced it. But I was quite disappointed because the final price is $150. And we know that we can, the hardware costs less than $12. So I think that is one important factor. The 96 board program was innovative in the way that they standardize things that are not being standardized before, that are the single board computers arena. We need to push, and maybe our model is a perfect matching for add-ons, where you have a lot of diversity. I mean, the question about the mezzanines, we have in track at least 10 designs. For example, the US Navy asked us if we can do a design to add a protocol to do maritime surveillance, the AES protocol. That's a UHF signal monitoring thing. We need to add software-defined radio appliances, cameras, tuners, and everything else, control automation. So I think our model fits very well on that, because on the IoT domain, you have this paradox that will somehow affect industry, because you need very specialized small series. So the IoT is bringing fragmentation. Somehow 96 boards fixed it, creating the standards. But very few people are populating the ecosystem of this standard. So yes, I think it's a perfect matching. Yes? Yeah, in the one-stop shop model, we need someone that quickly can outsource the components. And Arrow seems to be interested in this. So if they deliver the components in time, we just process them, certify, qualify, do some preliminary testing, and give it back, you know. So the whole idea is narrowing this timing, you know. Because in traditional formal methods, they will talk to you about lead times. Well, we need to spend 6 weeks to have the components available. They will talk about, well, this amount, this volume doesn't interest us. So we clearly understand that is a barrier for innovation. It's part of the gap, access to manufacturing. And we see another industries having the same model. The same model had been started with Raspberry Pi, you know. The university guys at Cambridge, they just find out a machinery nearby, you know. So the way how we're looking for is a model that can be replicated. I had visited many US universities, many labs, South Carolina University, for example, and they have the same kind of equipment available, no? So the question is, they never structurize a process to deliver it. And again, as John mentioned it, universities are just the platform. For example, we cannot sold out anything. That's why we had the startup companies that can do that quickly, you know. For example, one company that we had started is named Vira-Lata. Vira-Lata is that kind of mud dogs, that they turn cans. And the idea was turnkey, turn hardware, you know. So this guy has 35 years experience manufacturing industry. So he knows the whole global process of outsourcing, procurement, quick response, and he knows that there is a value on this. But when we talk about value, it's reasonable value. We're not talking about multiplying the product by 500, 700%, because again, you block the innovation, creating cost barriers. So the whole plan is to see how we can optimize a process for a small series to foster innovation. And always there is a niche where people can make money on this, especially small or medium-sized companies. But they need to think completely different from what they thought before, in terms of the whole vision of industry is processing and manufacturing huge amount of components. There is still a model where you need up to 10,000. So we had limited ourselves up to 10,000. More than 10,000, you can approach Foxconn, you can approach traditional manufacturers. So in purpose, we locked ourselves to any manufacturing below 10,000. If you need more than that, we have at least 3 channels that can take care of this to you.
So, mezzanine parents for the 96 sports ecosystem, your volumes are going to be 500, 1,000, well under that 10,000. So, up to 10,000.
Yeah.
I don't think you need, for any individual mezzanine, you would not hit those volumes.
Yeah.
At least not at this time in the life of the 96 sports.
Yeah. But when you cross this number, players like Arrow, Foxconn, yeah, so and we have partnered with these guys. They understood very well us that volumes below that is quite complicated for them. So that's why we had created this business plan around.
A lot of the time, this surface mount technology machine is idle.
Yep.
Because they don't have anything to produce.
And we doesn't accept high volumes. That's another problem.
So this program actually gives the university a chance to teach how to manufacture and install and therefore larger amounts. So it's not just about producing parts, it's about teaching the students and the manufacturing process.
And also because in few years, everyone will be able to buy this machinery at home, maybe.
I'm thinking about I'll call it the gap between ideas, design, manufacturing, and then sales. So if I have an idea, I can hand it to you. Your teams, your students have all the capabilities to do all the design work. You have the ability to do the manufacturing. It's the last step. How do we sell it and distribute it worldwide?
That's where companies like Arrow.
Yeah.
Okay. The problem that we've seen is that when people want to buy these things in a quantity more than 1 or 2, they say, I need 400 of them. That companies like Arrow say, well, no, it's going to take you 5 months to get that because we have to put it out. If we can do this the right way, then we can produce these a lot faster than 4 months. It might be 8 weeks, which is fine.
Yeah, companies need to take care of that, and sometimes we need to have access to global distributors. It seems that companies like Arrow, for now, are quite interested in this. Sometimes they even have problems. I try to design some stuff quickly, and I try to access. I was just discussing with them recently. Even these global companies, they have some limitations because they are not structured to be. Usually, companies, they take control of everything. Companies like Samsung, LG, they control the whole supply chain, The question is how we do that on organizations like Linaro, where we foster innovation, So we need to address this problem and try to break the barriers, For example, one of our companies that we had a startup, they had an office in London. We are discussing with John to have another office in California, because these organizations, they can trade from the legal point of view too, That's a concern from the university, So we are imagining, we have already one company with an office in London, so all tax structure and paperwork, they can fix it. And we always consider to have an office in California, to help in the logistics, distribution, and also certification. So one idea that we have, most of the specs regarding certification is the same everywhere. The idea is do pre-certification, do the pre-analysis reports to when that makes sense, and then see the specifics in every, for example, NIST and the Brazilian equivalent are very close. So mostly of the standards are accepted by NIST and FCC are the same in Brazil. So why replicating this job? We can do a basic certification, keeping all documents for auditing purposes, and try to minimize these costs in regions,
In Brazil, a Raspberry Pi, one detail will cost you about $150. Right? If that's what you pay for a $35 computer, imagine what you would pay for a $99 computer. We should be able to manufacture these computers and sell them in Brazil for about the same amount of money as they would cost to manufacture in China. A little bit more because of some of the issues around some things. But the more we produce, the better we'll get at this, and the lower the price will come.
Yep.
And this is not just about Brazil, because the working so agreement, if you manufacture something in Brazil where you create more than 22% of the value, then all of the other Latin American countries that are part of that agreement have to take it without any more agreement. So Argentina, Uruguay, Peru, Paraguay, all be able to take advantage of this.
Yeah. Okay, I think that's it. Another question?
I was just curious, you mentioned that this kind of machinery could be in the future sold to home users. Do you see this really happening? Because there's a large knowledge base you could have in order to design your own PCB with all the
Yeah. You are correct. I am a professor on electronics design, so I'm observing it. But take a look in this equipment from LPKF, The oven costs something like $6,000. The feeders, something like $12,000. The most expensive machine is the laser, is the UV laser for cutting. But that you can have as a service. But anyway, with less than $30,000, you can build a very professional. And LPKF is a high-end German company for precision machinery. But with less than $30,000, we bought the equipment. Because since we have a huge machine, always you have some loss when you produce anything below 100 boards. So it doesn't make sense activating a machine that has 25 meters long for, let's say, building 10 boards. That's why we bought this extra equipment. But when we bought that, it was a tremendous surprise to us because the technology is being democratized. And then this guy that I partnered that have 35 years of experience in manufacturing, he came to me and said, you know why 90% of projects failure from the electronics point of view is because they never consider the manufacturing. And I agree with him. He started to teach me the whole supply chain process. If you see, have you heard about this company, Altium? It's a software layout company. You know what is the most cool thing in this company? You finish the layout, you press a button, it brings out to you the codes in the traditional silicon providers. So DigiKey, Mouser, they quote automatically the bill of materials to you. and you press the button, press your credit card. 2 weeks later, you have all components to your design. And unfortunately, even as a professor, I need to pay $1,000 per year signing this service. So even newer tools for design, they are being connected to the global suppliers, you know. So I truly believe that in the next 10 years, manufacturing mezzanine boards and things are the industry is looking how to adapt to this new trend. But anyway, it was unimaginable few years ago buying this equipment and building yourself at your lab, you know.
I was in the plant in Brazil called Campus Party. It's a week long where there are a lot of hackers and stuff come to this event. I saw a kid sit down, design a circuit, simulate the circuit, break a PCB board, and took it into the bathroom to varnish it, to make it. He drilled some holes and put it together and assembled it right there at Campus Party. Now, granted, because the circuit's not where we make that as through holes, but he did the whole thing right there. And if you think that $30,000 is a lot of money for the equipment to put in your house, imagine that in a hacker lab, where everybody in the community is contributing money to buy the equipment and they share it. Okay? So this is
So I promise to you guys, it depends if Linaro will accept, but in the next Linaro in Bergen-Gale, I can have a talk about the 4.0 industry in this sector. There has been a revolution in the way how we do manufacturing because industry is understanding that we need to manufacture in small cities. What we have a lot of care here is keeping all my equipment certified. You know, sometimes at the universities, people forget about that. I spend a huge amount of money, more than $10,000 per month, just to guarantee that our equipment is certified. Because if we guarantee this certification, we can for sure drive mezzanine boards, everything else. Because as soon as they work, the next step is the certification. And you need to have it pre-certified, because if you pre-certify that, you doesn't need to do reworking in your design later. So that's our lesson with industry. You should have an attitude, since from the beginning, believing that your product will be in the table everywhere. You know? So if you need, I can give you more details about the machinery. In fact, they are pretty cool toys, you know. They have pressure, you know, they suck the components. This one is a small robot, you know. The oven has a precision of almost 2 degrees Celsius, you know. So you can have a very precise, you guys see the camera adapter to the mezzanine board of the Dragon. The problem of camera sensors, if you hit them too much, you destroy the CCDs. That's why usually the sensors are attached later, you know. Because if you break the sensor, you can destroy the camera. So in this kind of equipment, that kind of super fine process, designing cameras, design microsensors, is what we're targeting for, you know, where you should have a very precise quality control. I have a Japanese postdoc, Brazilian descendant. He spent 1 year in Japan just learning how to design ships, boards with sensor cameras, you know. Because if you hit them too much, you lose color control, everything, you know. Okay, thank you. I think it was excited.